Hey there, students. Welcome back. Got a lot to talk about today. Remember, Friday, tomorrow is our quiz, and it will focus on the key terms, of course. And really, even though I'll be going all over the board today talking about the things that we did in class and the things that we've done this week, the main focus has been radiation, radioactive decay, how we use it, its benefits, its dangers, its risks, things along those lines. So everything about radiation is really the theme, and why we learn about it so much right here at the beginning of the year. And I will explain the hat. Again, I've worn this hat before on a video, but today I will be throwing myself under the bus. Next week, we spend the week throwing Elon Musk under the bus, which is always fun. Haven't heard back from him yet on that one, but we do that because he talks a whole lot about colonizing Mars, and we're going to talk about, well, yeah, maybe in a couple centuries, but right now we got to take care of what we have right here, and also some of the challenges that come up when you're talking about trying to colonize a rock 1/3 the size of the Earth out there deeper in space than we are from the sun. So let's jump on in. This scene is our jumping off point. I wear this hat because of radiation that comes in from the sun. Ultraviolet radiation specifically, so let me take it off now. The other day, just after school, I ran on down to the dermatologist. You know you've got some UV issues from your childhood and from your teens and 20s when you're on a first-name basis with your dermatologist. She took a couple things off. My brother has the same thing. He's a little bit older than me, and so we end up having to go once in a while because of ultraviolet damage that has occurred in our cells because of exposure to the sun when we were much younger. This gets into, as we move forward in our chapters about the cells, this gets into DNA and how the DNA, the deoxyribonucleic acid, is damaged by radiation. When we're studying radiation this week, I'll get to this scene here in a second, we've been talking a little bit about what are the benefits of radiation, how does it help, for example, treat and diagnose cancer, what are the risks of radiation? In other words, how does it help, unfortunately, cause cancer? How does it start cancer? And to that end, let's talk about this scene right here before I turn off the projector and I get into today's notes. You might notice we have a nuclear reactor back here in the background. It's kind of dying, I'll just point it out. A nuclear reactor there in the background, which looks a little bit like this flask. We had a flask the other day in class, water boiling underneath it, heat underneath it, causing the water to boil. And when you look at a nuclear reactor, it is essentially a tea kettle. You're looking at taking radioactive material, getting it together, a lot of it in the same place at the same time. What are we doing with it? We're heating water. Now, in this particular case, in twisting the dragon's tail, and again, I highly recommend this. This is Dr. Derek Muller over here, if you can see him. This is Dr. Leslie Dewan. She's talking about how radioactive material in the nuclear power plant and future nuclear power plants can be safer than some of the ones that we've had in the past. Why would we want to flirt with nuclear power anyway? In other words, we've seen Chernobyl this week and some of the radioactive exclusion zones they have there because it had an accident back in 1986. We checked out today the results of the 2011 tsunami and nuclear accident in Japan caused by an earthquake. Well, certainly it's very, very dangerous when there's an accident with these right here. But on the flip side, if we can make it a bit safer, this is the pros versus the cons, if we can make it a bit safer, the smoke, if you will, that you see coming out of the top, it's just water vapor. That's part of the reason why we were boiling this just the other day. Also, we were talking a little bit about phase changes, liquid, solid, gas, that sort of thing. But when we were talking about in terms of nuclear reactors, what you have spewing out of the top is just water vapor for the most part. When you're looking at the way we get most of our fuel nowadays, most of our electricity nowadays, we use fuel in the form of coal and oil, and we burn that. Remember, when we're burning the coal and the oil, we're putting, among other gases, up into our atmosphere, carbon dioxide. Remember, that's acting as a blanket. It's holding in heat, and we're warming our biosphere that way. That's really the heart of climate change. That's the heart of global warming. So getting from there to where we started today with our brain pop, let me turn off the screen right here and bring over our first screen that the students had today. Our brain pop today had to do with a little bit of a review. Let me get this lined up if I can. The North Pole, what's the difference between the geographic North Pole and the magnetic North Pole? to that end, we went outside with compasses. We had the students, where's my compass? We had a couple, it's my geology compass here, but if you check out the compasses the students brought outside, we are comparing magnetic north, and also if you happen to have a cell phone, say for example, an iPhone, we had the difference between on the phone and the compass app. You can set it to go to true north or magnetic north, so we show the difference between those. Slightly off right here. And when we went outside, we checked out the shadows. We went out there, marked the end of one large post shadow, went out about 15 minutes later, made another mark in the ground with a piece of chalk, drew a line between them. That was our east-west line. Once you know east and west, you can tell north and south. So it gets to the magnetic North Pole is where compasses point. The geographic North Pole, let me pick this up right here, is the point around which the Earth spins. You can imagine a pole through the Earth and it's spinning like this. That is the point around which, the imaginary point around which we spin. The idea between the two is it's very, very important to understand the magnetic North Pole and the geographic North Pole are not exactly the same, and the magnetic North Pole moves around. We also learn about that now because later on, when we go deeper into geology, knowing the magnetic north and knowing that the magnetic north and south poles flip every once in a while was one of the key pieces of evidence supporting plate tectonics. The idea that plates, our Earth's crust, move around very, very slowly over time, and we can chart that movement partly in thanks to our knowledge of the magnetic north and magnetic south poles. All right, when we're looking at what is keeping those plates moving, this circles back to radioactive decay. Again, this is why we do it so early in the year. When you take our entire planet, if you do a calculation on, say, making a pie. If you make a pie and it cools off, you can't eat it right away, but as it cools off, you can eat it and you notice it's still warm on the inside. If you do a calculation on our Earth being 4.5 billion years old, it should have cooled more significantly than it has. This was troubling scientists for a long time. In other words, why isn't the Earth colder inside? Turns out there is some leftover heat from the formation of Earth, but there's also heat being generated by radioactive elements down deep in the planet that keep things moving, keep our planet dynamic, and not only does it move the plates, but it gives us a magnetic north and magnetic south pole. Important for a lot of reasons. We move on over here. When we check out Mars in particular next week, as we get into life on Earth, life in the solar system, and what makes Earth so incredibly awesome for life, one of the things that helps protect life on Earth, is our magnetic poles. It makes a magnetosphere, basically a magnetic envelope around the Earth that shields us from particles coming in from the sun. Mars does have a magnetic field, but Mars is smaller. It's much, much weaker. Mars has cooled off more inside than the Earth has. The magnetic field being weaker means it doesn't have as much protection from the punishing radiation from our sun. So one of the things that's helped protect life, and we'll go into more detail with this, has been our magnetic field. Why do we have a magnetic field? Partly it's thanks to the Earth being molten inside. Why is it molten inside? That's partly thanks to radioactive decay. So I'm trying to show how this stuff comes together here. And to that end, when we talked about my hat and ultraviolet radiation, we have a natural ultraviolet radiation shield called the ozone layer. That ozone layer is there because oxygen, high in the atmosphere, gets together in a molecule of threes. It's got one double bonded to another oxygen and a single bond to a third. The point is O3, ozone, helps protect us from UV radiation. Mars, no ozone layer. Now there's a lot of reasons for that, but even if you were to place an ozone layer around Mars, let's say you could go there and pump out a bunch of oxygen and try and put an ozone layer around Mars, the solar wind, those subatomic particles streaming out from the sun all the time would strip it away. In other words, when we're looking at Earth being a perfect place for life, when we're looking at the silliness of trying to put large-scale human colonies on Mars right now, sure, we might do it someday, but if you were to go to Mars now, you would have to spend a significant amount of time either underground or in shelters that protected you from the punishing UV radiation. So radioactive decay keeps our planet dynamic. It gives us a magnetic field because it keeps circulation going within the planet. And it's one of the reasons we have our nice protective shield around our Earth known as the ozone layer. It's also one of the reasons the UV radiation is why I wear this hat now all the time when I'm outside in the sun, along with long sleeves. And again, trying to keep the class practical going forward, especially as the young people that are watching this. Wear your long sleeves, wear your sunblock, wear your hat, wear your sunglasses. Because even though when you're younger you might not think too much about 1 or 2 sunburns and things like that, turns out later on it's a big deal because the cumulative effect, the cumulative radiation damage that you end up on the inside of your cells can eventually lead to skin cancers. And if you look at skin cancers, it's not something to be taken lightly. You might know, or your parents might know, the singer Jimmy Buffett. We used to see him in concert all the time. He unfortunately just passed away, and it was due to damage from UV radiation, from skin cancer. Skin cancer can metastasize. It can go to different places in the body. Make sure you're protecting yourself against the sun. Okay, getting back to our lessons up here today, we saw the very end of Twisting the Dragon's Tail. And remember, once again, we were talking about the pros and the cons of radiation and how we use it. Certainly the pros were we saw it's useful in cancer diagnosis, useful in cancer treatment. We can concentrate gamma rays on specific cells that are in a tumor, kill those cells instead of bathing the whole patient in radiation. But on the flip side, we saw Chernobyl, we saw the Fukushima Daiichi plant in 2011 that was damaged by the tsunami. When a nuclear power plant has an accident, it tends to be a very severe accident. Large areas will have to be evacuated for hundreds or thousands of years. And finally, we finished up with looking at, with the video anyway, with checking out Dr. Muller and Dr. Dewan talking about a future generation of reactors that, one, if we can bring those online, they would definitely be cleaner for our atmosphere. They would not have nearly as many global warming gases being spewed out. And they would be, especially as power demands go up in the world, it would replace fossil fuels, which are doing a great job right now of warming our biosphere. All right, that's where I'm going to leave it today. Again, check out the notes online. I know I covered a lot of ground today, but I'm trying to keep it within roughly 10 minutes and everything. And the key terms tomorrow will be the focus of the quiz. Take care of yourself. Have a good week, and I'll see you online. Bye-bye.